Okay, guys, for this lesson today, we're going to talk about rational graphs. And in our previous lesson, we had talked about just being able to look at the equation and determine where you had holes, vertical asymptotes, horizontal asymptotes, and zeros. Now, we're going to apply those to the actual graph and look at what that translates to on the picture. When you first look at an equation, I want you to decide, hey, is this a toolbox function? Is this one of the ones that I have memorized? It could be 1 over x or 1 over x squared just shifted. So you could possibly have something like y equals 1 over x minus 3, and that is a toolbox function that's just been shifted to the right 3. So you can think about what it looks like and tell me what the horizontal asymptote and vertical asymptote are, and that it has no holes. But you should be able to, sketch that graph. Let me try to draw straight here. You could sketch that graph. It's just moved right 3, so it would be over here and here. And the same thing would be happening if you had the 1 over x squared. It just would have the 1 over x squared shape that you have memorized. Okay, if it's not one of the toolbox functions that you have, then what we did yesterday, or what we did in the previous lesson, applies. So you want to find your horizontal asymptotes, your vertical asymptotes, your zeros, your holes, and then you want to make sure that you clearly mark and label those on your sketch so that you are including everything that is important about that graph. Once you have those marked, you want to get the shape from your calculator. There are different ways to get the shape. You could make tables of values, by plugging in x values and getting out y values and plotting those points. But for our purposes, I just want you to get the general shape from your calculator. In other words, plug the equation into y1, find in a good window where you can see most things, and see where the curves end up. That's what you want to use to get that shape for when you sketch it. Okay, something important to keep in mind that you may not have known before is that when you have 2 or more vertical asymptotes, the middle of your graph may or may not cross the horizontal asymptote. I have 2 examples here. Here we have 2 vertical asymptotes, and the ends, they're getting close to them, but they're not crossing them, so this end and this end. But here in the middle, it does cross. Sometimes funny things happen in the middle, and so this is okay. It doesn't mean you don't have a vertical asymptote. A horizontal asymptote. It just means that it's only affecting the ends. The ends are only affected by the horizontal asymptote. Here's another situation where we didn't have 2 vertical asymptotes. We just had 1, but this graph kind of crossed the horizontal asymptote in the middle. The horizontal asymptote affected it on this end, it just didn't affect it right here. And again, that's okay. When you do the math and you determine that there's a horizontal asymptote, it is affecting the end, at least. But don't be thrown off by funny things happening here. Okay, the first example that we're going to look at here is g of x equals 3 over x minus 2. So I'm going to write down everything I know. I do want to point out that with the 3, if that were a 1, you would have 1 over x minus 2, which is a shift of your toolbox function. So we'll probably be able to get the shape of our graph from knowing what the 1 over x graph looks like. So again, let's go over here and get our information. Horizontal asymptotes, you're looking for the power of x on top and the power of x on bottom. This is a no x on top situation, so small over big. That means you have a horizontal asymptote at y equals 0. Vertical asymptotes are what gives us a 0 on the bottom that isn't already a hole. So we should probably look at the holes. And since nothing cancels out, we have no holes. Now let's look at what gives us a 0 on the bottom, and that would be a 2. So we have a vertical asymptote at x equals 2. Zeros would be where the top is 0, and the top is never going to be 0 because the top is always 3. So there are no zeros. That just means it does not cross the x-axis. Alright, when you come over to do your sketch, I want you to make sure you clearly label the things that you came up with here. Horizontal asymptote at y equals 0. I'm going to do that with a highlighter so we can see it. So horizontal asymptote here, because it's on top of the axis. And then we have a vertical asymptote at x equals 2. So here's x equals 2. Here's our vertical line that we're not crossing. So those are the things I want you to make sure that's clear on your graph. Now we notice again that this is like a 1 over x graph that has been shifted right to. The 3 would be a vertical stretch of it, so it'll be stretched vertically from the normal. But it's going to have that same upper right and lower left curve that you would find on the 1 over x graph. And we're done with that one. For our second example, we're going to look at f of x equals 2x minus 1 over x. So I want to go ahead and look for anything that cancels out, and it doesn't, and there's no factoring to be done, so there are no holes. My horizontal asymptote, we look at the powers of x. I have the same power of x on top and bottom, so I use the coefficients 2 over 1. So my horizontal asymptote is y equals 2. Then for my vertical asymptotes, I'm looking at what gives us a 0 on the bottom. And since it's just a plain x, it would have to be 0. So my vertical asymptote is at x equals 0. And then finally, my zeros are what gives us a 0 on the top. And this might be one of those situations where you have to do your scratch work and set 2x minus 1 equal to 0 and solve. Or some of you might be able to see that if it was a 1/2, 2 times 1/2 minus 1 would give us a 0 on top. So we're going to have a 0 of 1/2. Now, I'm going to come over to my graph and I'm going to make sure I show those things. Horizontal asymptote at y equals 2 means I have this horizontal line right here that I'm getting close to on the ends, or at least one end, sometimes both. Vertical asymptote at y equals 0, again, I'm on top of the x-axis, so I'm going to use a different color so you can see it. On top of the y-axis. And then finally, our 0 at x equals 1/2. So I should cross at 1/2 right here. And then we use our calculator to get the main shape. So take a moment, pause, graph this in y1 and get your shape. Now that you have your shape, you will see that the upper left corner is a curve. And we're getting close to the horizontal asymptote on this end. And then we have a curve that fits down here, and make sure you go through the 1/2 point. We get close to the vertical asymptote here, we get close to the horizontal asymptote here. Here's the main shape of our graph. Okay, for our third example, we're using f of x equals x over x squared minus x minus 2. And this is one of those situations. It's easy to figure out the horizontal asymptote first, since you can see the powers of x. We have x to the first power on the top, x squared on the bottom, so this is a small over big situation. Your horizontal asymptote will be at 0. Before you can do the other stuff, you need to factor the bottom. So I'm going to factor using my x factor, trial and error type factoring. Becomes x plus 1, x minus 2. Now I can see when I check for holes, nothing wants to cancel out, so I have no holes. And what makes it a 0 on the bottom would be negative 1 or positive 2. So vertical asymptotes at x equals negative 1 and x equals positive 2. Then the zeros, what gives me 0 on the top, would be 0. So 0 at x equals 0. Okay, and then I come over to my graph. Horizontal asymptote at y equals 0 would be on top of our x-axis. so here. Then our vertical asymptote at x equals -1 would be here. And our vertical asymptote at x equals 2 would be here. And so I've kind of chunked up this section of the graph. Now, I have one last thing, the 0 at x equals 0. So I want to make sure that I have that dot there so that when I draw it, I cross through that point. Take a moment, pause, graph in your screen, in your calculator, and get the shape of the graph. Now that you have the shape of the graph, you will see that we should fit into this corner. In the middle section, we'll come down, go through the point at 0, and then approach this vertical asymptote on the right side. And our final curve is in the upper right corner. And you may be able to draw a little smoother than me, but this is the general idea for what's going on. On a test, I will be looking for you to show these things that we're writing down in your drawing. Okay, for our last example, we're going to use f of x equals x squared minus 9 over x squared minus 2x minus 3. So again, before I factor, I want to look for my horizontal asymptote because it's easier to find in this form. I have the same power of x on the top and the bottom. Both are x squared as my highest power. So I look at the coefficients, which are understood ones. 1 over 1 is 1. So horizontal asymptote at y equals 1. Now, to find the others, I need to factor, and the top is your difference of perfect squares. So that should factor to x minus 3 and x plus 3. The bottom is your trial and error factoring, where we use the x factor. So that's going to factor to x minus 3 and x plus 1. Alright, now, vertical asymptotes, wholes and zeros. We need to find the wholes first. I want to cancel out these x minus 3's. So that tells me I have a whole. And what makes that 0 is a 3. So I have a whole at x equals 3. Then if I look at the bottom, what's left? What makes that 0? Well, if I plugged in a -1, I would have a 0. So I have a vertical asymptote at x equals -1. Finally, I look at the top. X plus 3, what would make that 0? A -3. So my 0 is at -3. Okay, then I'm going to come over here and make sure I show those things. Horizontal asymptote at y equals 1. So right here. Vertical asymptote at x equals -1. Okay, have those in. The whole, you can't really put a hole right now because you're not sure where the graph goes, so you'll have to wait on that one. You can put your 0 at -3. You want to make sure we're crossing the axis at that point. Now, pause and graph this in your calculator and see what the shape of the graph is. I do want to point out before you do that, make sure when you're graphing in your calculator that you put parentheses around the top and parentheses around the bottom if your calculator doesn't show up the fraction form, so that it keeps it all together and gives you the right graph. Now, graph it. Okay, so with that graph, you can now see that this side goes in the lower left corner through that point, and we should approach the asymptote. I probably should add on a little bit on this side. Up here, we're going to come down and do the curve up here. Something that you can't see on your calculator is that hole. Our hole's at 3, so when we get to 3, we need to make sure to put a hole in the graph. Your calculator likes to connect the lines, so you will not see this unless you look at the table. If you have graphed it and you want to hit the table function, you will see that there is an error at 3, and that's because of this right here. When you do this on the test, I want to see this. If you have it connected, I know that you've just typed it in your calculator and you haven't done the math behind it. So make sure to show all these details. This is the last example, so you can now proceed to do the assignment.